going to see on the questions review. This is the volume flow rate. So like the one you learned. Okay, so volume flow rate. Okay, so you can calculate. Okay, so the mass flow rate using. Okay, because you have the density, mass over volume. Okay, so you can calculate the mass flow rate using density and also volume flow rate. Okay, so previously in the lab, so you know that, so when there is a temperature changes, so meaning that you have the Q value. Okay, so QH equals to M dot, so Cp delta TH. Okay, so same concept. Okay. Right, so QC equals to M dot Cp delta Tc. Okay, so we are going to play with mass flow rate. A lot of you make mistake, yeah. So in your lab report, so you would give me the equations Q equals to MC P delta T. Okay, so with the condition, so you use the equations when there is no phase changes. Okay, so no phase changes. So Q equals to MCP. So if let's say that inside that, okay, so suddenly, so let's say that you have the hot waters or the cool waters here. So after some time, so they form phase changes. So here you change the equations Q equals to M dot L. So this latent heat of fusions, you have two latent heat. Okay, so latent heat of fusion. Another one is the vaporization. Okay, so latent heat of fusion, so you get from the property tables. So from liquid to gases, so you use latent heat of vaporization. Fusion is solid to liquid. Okay, so solid to liquid, so you use the latent heat of fusion. Vaporization is liquid to gases. Okay, so if let's say that one of the system here, they change on the phase with the changes in the temperature. Okay, so you use Q equals to ML. Okay, so the one remain at their own phase. Okay, so remains their phases. So we will use Q equals to MC delta T. Okay, so similar concept here. So counterflow. Okay, so QH equals to M dot Cp delta TH. Okay, so QC M dot Cp delta Tc. Okay, so delta TH is using TH1, TH2. Since you know the directions already, so it's a positive answer. Okay, so delta Tc, Tc1, Tc2. Okay, so the temperature changes between cold water, inlet and outlet. Okay, so same concept here. So delta TH, TH1, TH2. Okay, so delta TC, so TC1, TC2. Modulus. Okay, so here if you look at the questions here, if let's say that this is calculations, so assumptions you make is 100% conversions. Okay, so 100% conversions, homogeneous temperature distributions. Okay, so if inside is the hot waters, so the heat transfer is from the center. Okay, so if let's say the hot waters is inside. Okay, so we assume that there is no radiations. Okay, so another equations, if the question asks you to calculate overall heat transfer. Okay, so 100% equals to, okay, so 100% conversion, supposedly QH and QC will be the same. 100% conversion, so QH and QC are the same. Okay, so if the question asks you to calculate the overall heat transfer coefficient, so which is the U value, so your Q value equals to UA delta log mean. Okay, so overall heat transfer coefficients, like I mentioned already, so it consists of inside the system, so you have the convections, you have the conductions, convection, so they simplified already. Okay, so it's U is actually is the overall heat transfer coefficients. Okay, so overall heat transfer coefficient, so this including so the conductions, convections, conductions, convection. Okay, so area is the one, which is the cone. Okay, so area here you're using is pi dl. Okay, so since 100% conversion, so this one can be QH, can be QC. Okay, so can be Q value, Q equals to UA delta log mean. So because 100% conversions, so Q actually this is QH, or if you get a QC value, so it's equals to QC. Okay, same to counter flow. So your QH can be equals to QC, can be equals to Q UA delta log mean. Okay, so if let's say the question asks you to calculate the Q value, for sure they will give you the U. Okay, so or the question give you the Q value, ask you to calculate the Q value, so meaning that they want you to calculate the A value, U value. Right, so U value mostly they will give you. Okay, or they ask you to calculate through the calculations. Okay, so here you will see that the delta log mean, you get the equation, so T1 minus T2 ln T1 T2. Okay, so like I mentioned, so you calculate on the first position, second positions. Okay, so T1 equivalents to the temperature difference between H1 and also C1. So I use modulus because it's positive answer. Okay, so temperature at second positions is the temperature difference between H2 and also C2. Okay, so counter flow a bit different, so you need to know because different flow. Okay, so first positions is you will have the same equation, so T1 minus T2 ln T1 T2. Okay, so T1 actually equals to your TH1 minus TC2. Okay, so T2 equals to your TH2 TC1. Okay, so you need to know. Right, so delta log mean here, so depends on the U value. If let's say U value given to you, so delta log mean in let's say they give you the unit is the W over meter Kelvin. So they give you in terms of Kelvin, so this is Kelvin. Delta log mean in Kelvin. If let's say they give you in terms of degrees Celsius, so delta log mean is degrees Celsius. So it depends on the questions. If the question asks you to calculate on the U value, so delta log mean is depends on you. You can give in terms of degrees Celsius, you can give in terms of Kelvin. Okay, so this one is optional. But if let's say U given, so you must follow this U value. Okay, so you must follow the U value for this. Okay. Questions? So far? Okay. Alright. So I think a lot of some of you make mistake in doing the sketching the curve. Okay, so we have the temperature profile. Okay, so temperature is temperatures against positions. Okay, so for parallel flow, okay, so this is your TH1. Because this is your first point, this is your second point. Okay, so first point, so TH1. Okay, so as first point here, so you have TH1, you have TC1. So you have TC1. Okay, so second point, so you have TH2, you have TC2. So it's a curve. Okay, so this is for parallel flow. Right? So another one is in counter flow. I think some of you make mistake. So this is the first position, so this is the second position. So at first position here is TH1 and TC2. Okay, so TH1, TC2. Okay, so second position is TH2 and TC1. Okay, so TC1, okay, so TH2. So a lot of you make mistake on this value. C1, C2. So the depth value. Okay, so this one for sure in final exam will come up. Okay, so I think very simple for you to score. Okay, so you need to know the value here. So because I noticed some of you in your report, so they use this is TC1, this is TC2. No, this is C1, this is C2. Okay, so same calculations as your lab. Exactly the same. Okay, so if you understand your lab report for sure, this part I think no issue. And then do not forget your assumptions. Okay, so a lot of you in your lab report missing the assumptions. Okay, questions? This one very simple. For sure, I think you can score. But then you need to be careful. Sometimes they may trick you. So they said this is some phases changes. They can have phase changes. We do one example. So play with the steam. Okay, so you see that you need to be careful because they said this is a rate of condensations. Okay, so they give you the area already, they give you the temperatures. You need to make assumptions that this is a counter flow or this is parallel flow. Okay, so you see the temperatures for this. Okay, so temperature of the steam is remain constant. So basically, if you see that the one having the same temperatures, one side having the same temperature, so the system prefers to have the counter flow. Okay, so this the questions give you, so the temperatures of the steam remain constant. So T H, okay, so TH1 equals to TH2 equals to 30 degrees Celsius. Okay, so TC1 they give you already, so 14. So TC2 is 22. Okay, so if you look at the temperatures for one phase, one side is the same. So normally this one they prefers to have counter flow. Okay, so normally they prefers to have counter flow. If you're using the parallel flow, okay, so if you're using the parallel flow, so normally the temperatures here outside output will be changing. Okay, so because if you're using the counter flow, so the flow, the waters having some friction forces and so on, so they normally they can achieve the same temperature. If you're using the parallel flow, okay, so you see that the friction forces and then to get up and out everything, so they prefers to have the heat transfer. So the temperature inlet and outlet here, so they will be changing. Okay, so if you want to maintain the same temperature, so here you need to add some friction forces. You need to have resistance forces to maintain the temperature. Okay, so if you see that one flow is having the same temperature, so normally we will make assumptions this is a counter flow. Okay, so if you learn on the physics, so if you want to maintain the same value, so you need to add some resistance. So some resistance, so the resistance actually referring to the flow. Okay, so you assume this is the counter flow. Okay, so counter flow. Okay, so you say that outside here is 30 degrees Celsius. Okay, so this one is 30 degrees Celsius. Okay, so it can be inside here. Okay, so this is okay, so 40 degrees Celsius. So this is 22. questions give you the surface area 45 meters square. U value they air value U value they give you 2100 meters square Kelvin. So they want you to calculate the mass flow rate. Okay, so and also the condensations. Okay, so they want to calculate the rate of condensations. Actually, is the H value, H value, or the L value, the latent heat of condensations. Mass flow rate. So it's the M value. M value for the cold water, M value for this hot water. Okay. So you by using this formula, so you can by giving these two informations, you can calculate the Q value. Q equals to UA delta log mean. Okay, so delta log mean, this is the counter flow, right? So delta log mean, your T1, T2, non T1, T2. Okay, so let's say T1 you use, okay, so it's a inlet temperature, so this is the first position, second position, so T1, so 30 minus 22. Okay, so T2 here you use is the temperature difference 30 minus 14. Okay, so you start inside. So U value known, A value known, delta log mean you known, so you know the Q value. Yeah, okay, another assumptions because you calculate on the rate, so time is constant. Okay, so you get the Q value. Okay. So this Q value, okay, so because it's 100% conversions, the Q value actually equals to your QH equals to a QC. Right, so you get the value already, you get the Q value. So you know that your phase changes. Okay, so head rate of condensations of the steam, so QH equals to ML. Okay, so QC, so there is no changes in the phase, so QC equals to M dot Cp delta T. C. You need to refer to the property table. Q value you will get is 1087. Okay, so you need to refer to the Cp value for the cold water. So Cp value for the cold water. Inlet temperature 14. So do the interpolation. You use the interpolations to get the 14 degrees Celsius. Okay, so use the interpolations to get here. get your CP. So around 4.2. I think it's around 4.2. Okay, so CP value referring on the inner temperature, so around 4.2. kJs, kg, Kelvin. Kilowatt or what? Kilowatt. Temperature is what? What? Q is kilowatt. Okay, so delta TC. Okay, so you know the directions. Okay, so delta TC you use 22 minus 14. Okay, so because it's a positive answer. Okay, so TC here is 22 minus 14. Okay, so you get the M dot. QC equals to your Q value equals to 1087 kilowatt. Okay, so then you get your M dot. So it's a kg per second. Yes, you calculate QC. You calculate on QC first. So, okay, because M dot is the one they said is the measure rate for cold water. So we solve the first part. So second part is the rate of condensation. So you need to calculate the M dot for this QH. M dot you need to calculate. So MH is your QH divided by the latent heat. Latent heat of fusion, latent heat for this stick. Okay, so you need to refer to the property table. So find the latent heat. Stick. Gases. Find the latent heat of stick. Okay, so you need to refer to the appendix table A9 because if you look at the previous one, so they give you is 100 degrees Celsius. So now the inlet temperature is 31. So you're going to see on this. Okay, so you hit find the enthalpy of vaporization. So the L value is 2431. Okay, so the Q value you can get is 1087 kilowatt. So the enthalpy of vaporization, so 2431. Okay, so kilojoule. If you're looking at the previous one, if you're looking at the previous first, what those so if you look at here, so they give you the value is 100 degrees Celsius. So the latent heat of vaporization is referring on 100 degrees Celsius. Okay, so it depends 100 degrees Celsius. So our inlet temperatures here, the temperatures that we use is 30 degrees Celsius. That's why we cannot take this 2257. Okay, so if you look at the boiling and freezing points properties, so the temperature is 100 2257. But here the steam temperature is 30 degrees Celsius. Okay, so that's why we referring on table N9. So referring on this. So here you get is 0.45. You need to find two. You need to find the mass flow rate. You need to find two. So one is for the cool water. Okay, so cool water because there is no phase changes. Okay, so second, the steam they said is a rate of condensation. So meaning that they undergo these phase changes. It's a condensation process. Okay, so that's why Q equals to mL. So that's why you need to be careful. Just like I mentioned, there are some system is one is having phase changes, and another one is remain as at their phase on phase. Okay, so phase changes Q equals to mF. So you see, this one is the vaporization or latent heat of fusion. So changes between gases and liquid or solid to liquid. Okay, get the answer? Get that? Okay, get already, then we do this second example. Okay, so second example, very straightforward. So it's the counter flow. Okay, so they want to calculate the U value. This one you get 32.5, right? The M for cold water. 32.5. For something. Very straightforward, sir. I expect you all can answer in final exam. The one I worry is you only the sketching of the curve. Because I think some of you make mistake in your lab report. Only the curve. The calculation part, I think no issue. Okay, so either they ask you to calculate the MS for it, or they ask you to calculate the U value. This one they ask you to calculate the L. Okay, counter flow, so heat exchange to heat the waters from 20 to 80 degrees Celsius. So your TC1 20, TC2 80. So M dot C they give you is 1.2. Okay, so the heating is to be done by these geometry waters available. So they give you pH1 160 degrees Celsius. They give you M dot. Okay, so M dot is 2 kg per second. Okay, so inner tube. Okay, so the diameters of the inner tube they give you. Alright, so 1.5 centimeter. Okay, so if the overall, so the U value they give you is, okay, so 640 watt meter square Kelvin. So now they want you to calculate on the L. Okay, so L related to the area. Okay, so you have the first information already. So from the cold water part, you can calculate on the QC. Okay, so M dot Cp delta Tc. You get the value. Okay, so you get the value already, 100% conversions. So your QC equals to your QH equals to your M dot Cp delta Th. Okay, so by using this equation, so you can calculate your Th2. Okay, so you get your Th2 already, you can calculate your delta log mean. Okay, so delta log mean you get equations T1 T minus T2 So delta log. Okay, so you get this one, delta log mean already. Then you can calculate on the Q value. Or you can get. Okay, so A value is your area equals to pi dl. So your Q value is 100% conversion, so equals to your QC. Okay, QC equals to U, okay, pi dl, delta log mean. So you get your L. Okay, so you get all this information because C value known, so mass flow rate known. Okay, then you need to know the CP value. Okay, so CP value you find from property table. What is cold water? Okay, so another one is cold thermal. Just copy, understand. Do it yourself. If let's say it's not in the property table, so you need to make assumptions. Geothermal what is the water? Supposingly they should give you, but then I think it's not in the property table. Okay, it's not given, and then it's not in the property table, so we assume that it's a water. It's not in the property table. Then we need to make assumptions already. Geothermal is water. Okay, then you refer to the waters. Here is 160. So another one, your CP value is 20. So 160. So it's a 4340. 160 is 4340 because it's in liquid form. Okay, so another one is at 20. So 4182. Okay, so your CP value for cold water. Okay, so for cold waters is 4182. Okay, so Joule, kg, Kelvin. So CP value for geothermal water, so because no geothermal water, so we assume this is a water, so it's 4340. Okay, so Joule, kg, Kelvin. Do not forget, yeah, your assumptions. I lazy to copy again, so it's the same assumptions. But then this one you need to add another one assumption. So geothermal waters. So it's the water. We use the property tables for the water because it's not listed in the table. Okay, so TH2 you will get is 125. Okay, so TH2 you get is 125 degrees Celsius. So delta log mean you will get is this is Kelvin, 91.9. Okay, so because the U value you use is Kelvin, so here is Kelvin. Okay, then substitute inside, you get the L. Your L value you get 109 meter. This one 125, yes, your TH2 is 125. Q value you get is around what, 301 kilowatt. Yes, around. Roughly, because I think I round off. You think should have some decimal place. I round off.
So we answer also cannot off.
3 decimal place. Your final answer for sure is 300.
The one also. The one like this one.
No, practice 3 decimal place. 3. This one I round, alright. I round off. You follow the one. So roughly around this answer.
In all step 3 decimal.
All step 3 decimal. Okay, so done Right, so last topics we already done. Okay, I think I haven't discussed the previous topics questions. So I return to these questions. Four questions I discussed, right? Okay, number 5. Questions number 5. You try to answer. This one very simple. So because it's a vertical, so you see the difference placement. So equations is given. So refers to the equations previously. Okay, so the question said already, this is a natural conversions. Okay, so natural conversions refers to natural conversions equations. Yes. Okay, vertical plate. Okay, so the first part is vertical plate, so they give you already know that number. Okay, so the first questions is it, okay, so determine the rate of heat transfers on the plate and natural convection. Plate is vertical. Okay, so this is natural convection that is placed vertically. So vertically, so you will see that the equations is, okay, so we're going to find on the entire, use the entire range to find the answer. Okay, because we you can calculate the range numbers, or you can calculate the brushes multiple by product, so you see on the range. Okay, so if you want, you can calculate on the range. Okay, so this is the natural conversions. So here you know natural conversions, we have the brushes number. Okay, so we're going to find on the firm temperature. Okay, so firm temperature is 1 over average temperatures. Okay, so we're going to find on the average temperatures. The firm temperature is, so they give you 90 and 20, 90 and 30 divided by 2. Alright, so we're going to find on the beta 1 over Tf in Kelvin. Okay, assumptions. So in this topic, the assumptions, you're going to see on the pressures. Okay, so pressures is, okay, so because this is the natural convection, so you will see that you make assumptions the plate is exposed to the air. Because the question doesn't mention, so they exposed to the air, so we assume this is to the air. So this pressure is at 1 atm. Okay, so pressure of the air is at 1 atm. Okay, so you get this value already. So the firm temperatures. So you refer to the properties of the air. Okay, so properties of the air at 1 atm. Okay, so you get okay. So if I referring on the form temperature, so which is the 60 degrees Celsius. So finding on you know, the densities, so the CP value, the K value, and so on. Okay, so 60 degrees Celsius, so referring on the 60 degrees Celsius. So here form temperature is plus 273, it's Kelvin. Okay, so you have the density, calculate on the density. 60 degrees Celsius is 1.59059. Okay, so kg per meter cube. Then your CP value 1007. So joule, kg, Kelvin. So K value 0.02808. Okay, so calculate on the alpha. I'll get from the property tables. -5. Okay, so the kinematic viscosity, the dynamic viscosity. Okay, so this kinematic viscosity. And product number. Just copy and get the copy. You need to give also the unit. Okay, so you know your gravitation, so this is a constant number 9.81. Okay, so just copy from the property table. So all this you need to copy here because it's you can get 3 marks for this value. So you can get 3 marks. Okay, so get already. So here you know, yeah. So the length here is this is L1. So L is 0.6. Okay, so first conditions. Okay, so you just step inside. Okay, so your L value is equal to 0.6 meter. Okay, so you can calculate your Grashes number. Okay, so you can calculate the Reynolds numbers equals to the Grashes number multiple product number. from the vertical plate, so we are going to use the entire range. Okay, so this normally, if you have this a vertical plate, so we will use this one because this is the accurate one. If you're using the first and second, so normally it's not accurate. So the third one is the accurate one. So normally I will use the third one to do the calculations. Okay, so then you sub inside the equations. Z numbers equals to 0.825 plus. Okay, so 0.387 Reynolds number 1/6. Okay, so 1 plus number. Okay, so 9/16. 8/27. Okay, so the whole thing. Okay, so the whole thing power 2. Okay, so you know your music numbers equals to your H L over K. So you can get your H value. Okay, so you can get your H value. Get the H value already. If the question asks you to calculate on the Q value, so HA, TS, the infinity. They ask you to calculate on the rate, so time is constant. If let's say you look at the questions, the H value given, so normally they use the simplest calculation method. Okay, so like in these cases, so the H value unknown. H value unknown, so normally refers to this topic. You need to calculate on the new Z numbers, you need to calculate the gracious numbers, credit number and so on. Okay, if the H value given, so you directly apply on these equations. It's the easiest question. Okay, so if let's say that the questions is does not give you any H value, so meaning that you need to find the H value. So you need to check back your gracious numbers, Reynolds number, and so on. H value you get is 5.944. Q value you get is 128 watt. Oh, sorry, 115. Music this one is 5.302. Music number you get is 113.2. Music number, brushes number, no unit. This one I think easy for you to score, okay? But with the conditions, you need to calculate correctly. Very simple. Yeah, the step is like this. Okay, get the TF from temperatures. Okay, so you calculate you get the value from the property tables. Then you calculate on the music number. Get the H value, then Q value. And there is another possibility also. If let's say this is the force conversions, okay, so this is a force conversion. So basically, you need to calculate on the Renault number. Okay, so for natural conversions, you calculate on the brushes number. But if let's say this is the force conversions, so you calculate on the Renault number. Okay, so Renault number. So then you identify this is the turbulent or laminar. Okay, so if let's say that okay, so you have the value, so like the 2,300 and so on. So that value you need to memorize. Then you identify on the laminar and turbulent. Then you get your music number equations, calculate on the H value. Okay, so for natural conversions is calculate on the brushes number. Okay, force conversions is calculating on the Renault number. Okay, so that's why this topic you need to memorize on the value. Value is not given. Okay, so you need to memorize. Then you identify which either is a laminar or turbulent. Okay, so first part very simple. Okay, so second part also apply the same concept. Okay, so second part also so now the hot surface facing up. Okay, hot surface facing up, again we have the formula. Okay, so horizontal plate, hot surface, okay, so hot surface on top. So you need to calculate on the Reynolds number, so see where they're falling. Okay, so now the characteristic length here, so you need to be careful now. So characteristic length. So now it refers to the cross-sectional area divided by the perimeter. Okay, so you get already. So you calculate on the Grasha's number. Okay, so by using the L value, D value, you get the answer. Okay, so you see that in the table, so they give you the Reynolds number. So calculate on the Reynolds numbers. So you see where they're falling. Okay, so you see where they're falling, then you come up with the music number equations. They give you is a square plate. So 0.4, 0.6, 0.6. So the area is
Well, like rectangular.
drawing ma.
So the perimeter is 4 times 0.6.
4 times 0.6.
0.6.
Perimeter, so sum up everything. 4 times 0.6. Okay, so area here is, okay, so area here is 0.6 multiple 0.6. So because they give you this plate, so is this surface exposed to this? So you get is 0.6 here, 0.6, then. Alright, so perimeter is 4 sides. Those are the same. So supposedly it's 2W plus 2L. But then they say this is a square ma. So actually equals here is your 4L. So 4 times 0.6. 4. Total length. Total. Okay, so this is 0.6, this is 0.6. Okay, so you get the answer already. Sub inside L. Okay, so I put LC here lah. Easy for you to see. LC, LC. Then you get the answer. You get the new Z numbers. The new Z numbers equals to HL over K. So this is LC, so a similar answer here. So you get the H value. Get the H value already. Q equals to HA. ES T infinity. So you will get this is 0.15 meter. Reynolds number you will get is 1.195 times 10 to the power 7. Okay, so you get already, so you get this range. So then you find on the property tables. So see which range. So this one actually starting from 10 to power 8. So those 10 to power 7 so fall in the first category. Okay, so including up until power 7. So this one actually start from 10 to power 8. Okay, so the one in the power 7 one, so it will be in the first equations. Okay, so the new Z numbers equations is 0.54 Reynolds number. Power 1/4. Okay, so you calculate your H value, you get the Q value. Very simple. Just looking at the property table. Easy, oh? Can score. This one 15, I think. Okay. If the question asks you to do the derivation, so it's 25. It's only calculations is 15. Okay, so third question is also very simple. Okay, so hot surface facing down. Okay, look at the property tables. So hot surface facing down. So the new Z number equals to 0.27. Okay, so third part. Okay, so facing hot surface facing down. Okay, so new Z number is equals to 0.27. Reynolds number 1/4. So Reynolds number are the same. This 1.195 because the L characteristic length are the same. Then sub inside. Okay, so you get the H. You get your H value. You get your H value, so you get a Q value. This topic all refer on the property table. Only the Reynolds numbers value you need to memorize. For the thin plate, for the cylinders, so what are the value? For the laminar, for the turbulent. If this, let's say this is a cylinder, so this L replaced with diameter. If let's say this is the cylinder, okay, so replace with diameter. Okay. So next questions. Okay, so they're exposed to engine oil. So we find the properties table for engine oil. Okay, so T infinity, so the engine oil T infinity, they give you 60 degrees Celsius. So surface temperatures, they give you 20 degrees Celsius. Okay, so they give you the length, so 5 meter. Width, you have the free stream velocity, so the velocity they give you 2 meter per second. So now they want you to calculate on the Q dot. So accept assumptions, okay? So calculating on at pressure 1 atm. Okay, so they give you on the Renault they give you on the velocity, so meaning that they ask you to find the Renault number. Okay, so they ask you to find the Renault number. Okay, so first thing first, so find on the firm temperature. So 60 plus 20 divided by 2, so which is 40 degrees Celsius. So beta 1 over TF. Okay, so per Kelvin. Okay, so find on the properties table, so engine oil. Alright, so you have the property tables for engine oil. So 40 degrees Celsius. So you just copy up. So density. So density 876 then the CP value, right? CPK. So just copy CP value 1964. K value 0.144. Alright, then we have the alpha mu. Right, 2177. Then you have B credit number beta. B value okay, so credit number. Okay, so the questions give you velocity. So finding on the Reynolds number. Okay, so finding on the Reynolds number. Reynolds number equations. Okay, so Reynolds numbers equations. So it's a velocity, density, L, X. Or you can put it the F. Or you can use another equation. So it's your VL divided by the kinematic. Okay, so V velocity is 5. They give you is a 5. 2. Yes, they give you is a 2. L is 5 meter. So this one kinematic viscosity. So 2.485 times 10 to the power negative 4. By the Reynolds number. Okay, so you find the Reynolds numbers. So you get is the value is 4 point something. You get is 4.07 times 10 to the power 4. The value here lesser than 5 10 times 10 to the power 5. So remember the critical Reynolds numbers. So above this value is turbulent. So below this value is laminar. So this one the value lesser than okay, so the value here lesser than, okay, so this is the laminar. Okay, so 4.07 times 10 to the power 4 lesser than this. So this one is lamina. Okay, if the questions doesn't directly give you the equations, okay, so you know. Okay, so here you will see that this is a lamina. Lamina already, then you find on the lamina equations. Okay, so you find on the lamina. So we will not use this one because this one is Rx, is the local one. We not access certain length. So now we are finding on the entire plate. So we are going to report on this. So lamina, so 0.664. Okay, so new Z number equals to 0.664. Okay, Renault number 0.5. Product number 1/3. If let's say the questions doesn't give you this one, you need to find. Okay, so you need to refer to the property tables to get all. You need to remember on the equations. Okay, you need to know this number. It's a thin plate. Okay, so value lesser than this is, okay, so Renault number lesser than, so it's a lamina. Okay, so lesser than this value. So this is lamina. So we're finding on the lamina. So you know, so Renault number, product number power 1/3. Okay, so new Z number here is HL/K. Okay, so you get the H value. You get the H value, you get the Q value. Okay, so the questions ask you to calculate on the Renault numbers. So this one referring to force conversions. If the questions give you in terms of the credit numbers, okay, so Grash's number, Renesh number, RA value, so that one is referring to the natural conversions. Okay, so if they give you is the velocity, they ask you on the Renault number, so normally that one is the force conversions. Okay, so this one they give you already. Okay, so given the user number. If let's say not given, so you need to you find Renault numbers, then you get the range, then you make conclusions. Okay, if not given, then you find from a property table. This one very kind, the questions directly give you already. So if the questions give you already, so you can skip this Renault number. Or still you still have the Renault number to do the calculation. Okay, so you still need to calculate. Okay, if the question asks you to identify, so this is the lamina and turbulence, so check on the Renault number. 5?
I have one. Assume
Okay, so you see that the question said if the plate is assumed to be, I think you can make assumptions the width is 1 meter because not given. Okay, so the width, the area supposedly is the width times by the length. Okay, so but in this question, supposedly they give you, but then the value width doesn't give you, so you can make assumptions. Okay, assumptions are constant pressure at 1 atm. So this one is the width is 1 meter. This one you copy with together with the unit. I lazy, then you cannot be lazy. Okay, so include all the unit. It's all about, so you'll see that all about table. This topic all about table. Okay, so we will have class on next Tuesday, 8 to 10. So we do revisions or we try to see whether you want to do mock test or not. If you don't want, I just discuss. I give you questions. Okay, if you want to try to answer within 2 hours, you can. Okay, then on Wednesday, so Wednesday and the last day you must come. So maybe you get some hints or
some money. Did more. I need more people.
Okay, I try to narrow down the scope. Okay, but last day you must come.
What the team? What the answer?
What is the answer? Okay, cannot remember. Q value.
What? Go negative.
Negative. Possible.
Yes, minus.
This one, if you know the directions, so you know direction, so you get the positive answer. So answer is around 1111. 11. Feeling
The point. Five.
Got point.
The point.
No one.
1101 point.
Got point or not? No point. No point.
My one got 1101 point.
My answer is this one. You try to calculate. Try to calculate. You want got point or not? 1 point
1101 point。哎，你是101啊？我也想1讲1讲，我这个。
11,000 or 11 point.
1049.1。
So you wrong already. 1 plus. No point. 1 something.
H1 H3 apa?
Thank you, miss.